Good morning, everyone. My name is Reema, and I'm Junior Research Fellow in CIBioD. So it's my pleasure to welcome all the participants who joined today with the session. So I welcome our speaker, Dr. Anuj Sharma, our principal investigator, Dr. Varindagar, our co-principal investigator, Dr. Harish, and Dr. Sakshi, and all the coordinators from our Brain-Trust Institute. Today, we have session role of artificial intelligence and machine learning in real-life applications. So before we start the session, I would like to play one video of CIBioD. Please have a look. Thank you so much for watching this video. So I request Ms. Ritika to please take over the session.
Hi, good morning, everyone. This is Ritika Mahajan, Metric Fellow, CIBioD, and I welcome you all for today's session on the role of AI and ML in real-life application. So before proceeding with the session, I would like to take the opportunity to welcome our guest speaker, Dr. Anu Sharma, esteemed faculty from the Department of Computer Science and Application, Panjab University. Dr. Anuj holds his PhD in Computer Science from Thapar Institute of Engineering and Technology, and he has pursued his postdoc from Germany. His core expertise is in pattern recognition and machine learning, and he is also holding a patent for the system and method for predicting badminton match outcome. Sir, it's an honor for us to have you with us for today's session, and I'm sure we will be enriched by your talk. So I would like to give the handover for today's session to Dr. Anu Sharma.
Yeah, good morning. Good morning, all of you. And I believe I am audible to all of you. Kindly confirm.
Yes, sir.
Okay, so let me share the screen. And so I believe the screen is visible to all of you.
Yes, sir, it's visible.
Okay, so once again, welcome. And first of all, thanks to CIBioD to call me for this talk. And so far, I have understood the CIBioD, it is doing an excellent work to upgrade the knowledge of citizens and giving new applications in the areas of health and innovations. So today my talk will be related to AI and ML, that how we can relate it to real life. I would like to give you a brief history of computer science, and then I will take you to AI and ML introduction. And I will give you a case study understanding that how COVID-19 spread in Chandigarh and how we are tracking its cases using machine learning. So I hope I try to complete my talk in an hour, but in case if time is beyond the expectations, please let me know in between so that I can cut short my presentation. And so as I told you, I will make my presentation into three parts. The first is computer science, history mainly, then AI introduction, and then case study. So as you can see this picture, this is of 1950s from IBM lab. This entire machine in a hall is one computer. And I believe that, just let me put this laser pointer. If you can observe this logo, this is IBM. This is the IBM machine. And not one, but we need multiple people to run this computer in 1950. These disks are the storage disk, which has taken up now shape of a portable disk and maybe of large size than these large disks. Then this entire machinery is CPU. Now we don't have to worry about what inside a computer, but that time the computer needs to be manually operated, especially the CPU part, as you can see the structure. But today we have witnessed that our machines are quite compact, quite fast, and we have more storage as compared to past. And that's what we say innovation is. Now, look at the future. The testing is already done by this Mitsubishi lab in Japan, and they are coming up with such devices that devices are more compact with more memory and more cloud computing based architectures are coming up. In addition, we have the senses mechanism also, where one can, what we imagine and what the visualization takes effect. So the future of computing is not far away because all this is predicted in next 20 years. There is a famous economics John's law, which states economy point of view that in 1982, $600 computers, in 2012, $600 computers, and by 2042, it is projected that 64 neuron implant chip could be in human brain of approximately $600. And that's where the indications are, and these all technologies for futures are looking feasible now. But yes, we have to take care of the intelligence factor of the same, and that's why where the need of artificial intelligence comes in between. And one more thing in between, that there are some commonalities in 1950s, today, and the future computing. This is about algorithms, software upgradations, implementations, the hardware, the scientific approach, and state-of-art technologies, and of course, our social needs. These were there, are there, and will be part of us. And if we look at these circles of computing tools, then if you observe, this is the firmware programming, which is definitely required at the bottom level of the computer. Then C and assembly language, which interact with this, then C++ and Java high level, then Python, MATLAB, and application tools, which we use for our daily routine applications. But what is interesting is that we have different set of peoples for each circle. But nowadays we observe this Python, Java, C++ is gaining attention from all the disciplines because of their interdisciplinary nature to work, easy to understand, and giving new and new applications. And as human is hungry for some artificial mechanism to work, exactly there is AI is coming, that is artificial intelligence. And the tools like Pythons are fulfilling that gap and giving us the new applications in that area. So he is the Python mind who developed, his name is Gyudo van Runsum in 1991. He took it as his personal project to develop a language which could be used by all the discipline, not only the computer science experts, but from all the areas of social sciences could use a common, easy to use language. And if we look at his academic profile, it is very interesting that he is master's in 1982. And since then, he took up a project in his mind to develop a language that could be used across the globe. He changed 5-6 jobs. He worked in Google, Dropbox, and he is retired now. But yes, in 1991, he given us a promising tool that is called Python. I will say here tool, not language, because now it is very much interdisciplinary and few people are using it as tool, few are using it as a language. So commonly we find this Python, people used to say it's tool, it's very good tool, right? So this Rossum, if we look at his journey for Python, in 1991, he introduced to us. By 2000, companies started accepting it. So if we understand the computing language from a graduate point of view, most of the people perform C language first, then develop some project in C, and immediately shift to higher level or other languages like Java, Python, MATLAB, etc. But what is the Python use for us? Python may not require knowledge of C language, but here is a very simple phenomena which most of the non-computing background students or professionals do. They start directly with Python, they start solving the problem and repeating it, and they become expert in Python. This in latest article was also published, that how Python community is increasing without having knowledge of other languages. And that's what researchers and academicians are following the same principle. Now, for the Python users, I would like to give your attention that in 2000, year 2000, the companies, major companies that time, like Fermilab was a scientific company, Yahoo, Linux, they started using Python. And in 2020, a gap of 20 years, the giants of today like Google, Facebook, Microsoft, they are using Python. In addition, the data science companies, which are talk of today in industries, they are using Python. So in a nutshell, we find that Python has taken a lead in all the areas of academic as well as industries, in research domains, and is very popular. And that's what it close to AI. So another advantage of using this language is the dependent tools on this. So the dependent tools, which are independent modules like scikit, numpy, keras, each one is having its own uniqueness and meant for a specific domain. And that makes Python more powerful. So this advantage is because any new package like SciPy or Pandas, any new comes, it can easily integrate it with Python, and Python becomes more and more stronger. And we have witnessed that today 200 established, 2000 at the second layer, and millions of packages of Pythons are available now. So with this understanding of computing, now I would like to take you to the introduction of artificial intelligence and its dependencies to tools. So before understanding the definition of artificial intelligence, let's look at it as a part of computer science. This computer science is having different areas from student point of view, like networking, AI, software engineering, and other subjects. Then AI is having its sub-subjects, or we say the subtopics: pattern recognition, machine learning, natural language processing, computer vision, and so on. But I would like to update you that these all fields are interdependent on each other. These are not mutually exclusive. One needs other field or other subfield topics or techniques, and a lot of interdependency. And sometimes it is very tough to distinguish between machine learning and pattern recognition. Then in machine learning, there are some specific techniques like regression, classification, clustering, deep learning, and so on. But again, here at this level, again, these are again interdependent, and clustering very close to classification, and so on. Then if we look at the classification, there are another methods like NN, SVM, decision trees, and so on. And again, these are dependent on each other. So in a nutshell, we have an understanding that computer science is composed of many sub-subjects, where AI is one of the area. AI is having many sub-areas. These areas are dependent on each other. And for some of the applications, these fall in multiple subfields. So that's how AI lies in the area of computer science. Now, what is AI? McCarthy in 1956, he was very clear about one definition, that is of AI, that whatever in human intelligence, if we can make it through machine, that's AI. And machine is what we say, an artificial device. So if human is original, then we say machine with that intelligence is artificial. And of course, with intelligence, the complete words come as artificial intelligence. This was what in 1956 proposed, and till date, this definition is there. And that's why there is one common understanding is that AI is something that what human can do, the machine can do. That's it, a very simple definition. And to establish this definition, this intelligence, in 1955, a test was done, that is Turing Test, on the name of Sir Alan Turing, who has given us the Turing machine, and he is the father of automata, we say, in computer science. So his test was, let's understand this test. It's very simple. There is an interrogator, and there are two sets. One is human, another is machine. And one cannot see each other. Human cannot see interrogator and machine. Machine cannot see human and interrogator cannot see human and machine, right? Now, interrogator is receiving the data from human and machine. If interrogator cannot distinguish between human and machine, that's what we say the Turing test is passed. Or in other simple words, what human can do, that machine can do. And that's what we say to identify in artificial intelligence, that how the machine could compete the intelligence with human. So there are many human behavior tasks like perception, reasoning, learning, language, robotic type of activities. So these are common human behavior. And the agenda is that can we have the AI capability? So these listed points are on the basis of today innovations in this area, like computer vision, robotics, natural language processing, speech understandings. All these are now the capabilities of AI. And let's look at the previous slide, the human behavior task. If we list these activities with these AI capabilities, we immediately understand that yes, AI is able to do these human capabilities today. Then these capabilities falls under some common working areas like machine learning, intelligent tutoring, multi-agent, uncertain reasoning, natural language, virtual reality, robotics, and so on. But these areas are not mutually exclusive. Again, they are dependent on each other. And now today, if we look at the industry's applications, especially from the Google, we find that the data is interpolated. The one application data is heavily used by other application and so on. So it's some kind of web of artificial intelligence we are observing today, that one data is not specific for one application, but being distributed to multiple capabilities of AI. And that's what makes the, we say, good data approach today in terms of machine learning. So with this AI introduction and what AI can do, I take you to now its subfield, that is machine learning, and how machine learning is helping us in our real life. So first understand that machine learning word came in 1959, immediately after McCarthy artificial intelligence definition. The field of study that computers the ability to exactly program or explicitly program. What does it mean? That in a traditional program, we have a program and data and we use to give outputs. For example, you want to add two numbers. So your data is two numbers and your program include A plus B and the output is sum of two numbers. But machine learning says, you have the data, the two numbers, you have the sum which you expect. Now let's derive a logic out of that. So that finding the close logic with respect to plus is what exactly the need of machine learning is. And that's why we say sum exactly or explicitly programmed is what machine learning is. Needless to say, in 1960, there was no thought that machine learning will take over the entire programming capability in such a way that human will least think about it. But no, with the advancement of hardwares, with more and more greedy approaches for business logics, put us in such a situation that machine learning became our need of hour. And of course, this is again artificially intelligence behavior. So that's why it's a part of AI. So the subfield of AI, as you see the content of this slide, that machine learning is a rule-based engine. We have some rules, we have to follow the rules, we have to go scientifically. There is nothing random in machine learning. Everything is explicitly based on algorithm and mathematics behind that. And any algorithm which is rich in mathematics is certainly going to give some certain results with the desired accuracy. And that's what the beauty of ML. And common real life applications where machine learning would help us today is, if you look at your Facebooks or other applications where face tagging is possible, gesture recognition, you play video games and gestures are recognized, the virtual reality, the today platform of sharing the data is one example. Then we have text and audio recognitions, robotics surgery is very common nowadays. Advertisement in social apps. This is something interesting because this is one of the good business logic nowadays. Every one of you must be using FB or Instagram, and every one of you gets some specialized advertisement. It's not common advertisements like television. So that is something based on some data understanding by the app of your user ID, and the respective advertisements are given. Then we have big data management like Netflix, medical imaging, and many ML applications nowadays. In a recent survey, it has been observed that we have closely 6,000 something ML applications which are in use, types of ML applications, and more than 7 million applications are directly or indirectly used. So we can say that ML is gaining attention day by day and in an exponential order. So machine learning types, if we see the human behavior to mimic by machines is AI. Then we have machine learning. The machine learning is enable machines to improve the specific task based on some training data. Then there are three types of common machine learnings. One is supervised learning. If you have the data with some labeled, you make it supervised. If your data, you are not aware of that labeling, it is unsupervised. And to perform with some max count is what reinforcement learning. And there are many examples of these, like supervised is classification, clustering, unsupervised is again used in clustering or classification. So we will understand this in coming slides. And now let me take you to this ML major parts, right? And this is what the end of second part, and then I will take you to the case study, right? So machine learning major parts are data understanding, regression, which is a rich statistical technique, classifications, clustering. So let's attend it one by one. Data understanding is the machine learning area where we have to understand the type of data. This appears to be very simple, but it is the most important and tedious task because understanding data is itself challenging one in nature, because human cannot understand the data clearly, and to make machine understand that data is a challenge. And not only the data, what type of data, but the normalization, the smoothness of data is another challenge by machine, because sometimes the normalization also results in loss of data. Then we have another major technique is regression. Regression is very statistical technique, and there are some common sub-technique, or we say the algorithms in regressions are linear polynomials, support vectors, decision trees, and random forest. And similarly in classification, we have logistic regressions, KNN, support vectors, decision, random forest. So when we will study case study of COVID-19 in Chandigarh, I will study about this regression and classification role, that how we can understand the data. So then we have clustering, the common types of clustering like k-means, hierarchical. It's not all easy to cover in today's lecture, all these definitions and their formulas, but those who are interested can take out this screenshot and can understand at their own that how each one is helpful in respective area of AI. Then we have natural language processing, deep learning, where artificial neural network, reinforcement or convolutionals are used. Then we have dimension reduction, which is heavily used in big data applications to reduce the data, but to make remain the data meaningful also, like principal component analysis or linear discriminant analysis. These are some common fields. Then we have other fields like hidden Markov model, online learning. Online learning is picking up the pace nowadays because this do not require data in advance. That is what the best part of online learning. As the data comes, the system start learning. That's why it is called online learning. And online learning, initial threshold could be high, but as and when data starts coming, the model learns so fast that in most of the real life application, it has been observed as a very good replacement to traditional batch-based system. Then we have elastic matching and genetic programming and many others. Genetic programming is again gaining much attention, especially in some of the bio-related field. The best part of genetic programming is its fast computation and understanding in terms of human, what we say, DNA mechanism type of flowchart, like crossovers, mutations, selections, fit of the fittest to survive. And that is all these concepts are in genetic programming and make it very powerful when being used from the machine point of view. So this all together makes our machine learning, and there are other, many other fields of like transfer learning, hybrid learning, many types of subtypes of machine learning, but these are some common algorithmic area where students, academicians, researchers can participate and can give some innovations in terms of real life applications. So now I would like to take you to the case study of COVID-19 in Chandigarh, where I would like to discuss you with the sector-wise understanding of COVID-19. And then I will give you a demonstration of Python-based program, of course, developed by me only, that how we can understand the regression and classification rule for that data. So let me shift you to, okay, could you ensure me if you can see these graphs?
Yes, sir.
Okay, so these are sector 1 to 5, as 1 to 5 is having very less population. So I have merged these sectors. So you can see the data is between 1st of October 2020 to 10th of June, right? So you can see that how these peaks, you can see these indicate the highest number of cases like here. So highest number of cases 1 to 5 in a single day is 7-day average. This is so weekly average. So you can say around 19 or 20, not more than that. So I will go fast here. We have other sectors. I will stop at few sectors. This is sector 12, which is close to PGI. You can see that the nature. And one thing is, I would like to update you when the Chandigarh peak of cases. So default, we all understand every sector is having the peak. So you will find this second, peak, the third wave, which was in January 2022. So you will find that every sector will observe a peak here, right? And then we have sector 14, which is Panjab University. And these are the cases of Panjab University. Then let me take you to sector 32, which is having a hospital, because sometime most of the admitted people are diagnosed with COVID-19. So we again observe this type of indication. Then let me take you to now. Yes, I would like to take you to Bapu Dham colony because it having the very first peak was very high. Then we observed less cases in second and third peak, relatively, I will say relatively word here. Then we have we have a lot of, like Dhanas, we have Faidan, Hello Majra, industrial area, Kamwala. Then now my interest is for Mani Majra. Yes, Mani Majra is having one of the highest number. The highest number of cases in Chandigarh is from Mani Majra in all the three peaks. First peak was during lockdown, so I will not consider that right now. But the second and third wave, if you see, the Mani Majra is having the most number of cases, right? And of course, maybe the population of Mani Majra is like that, but the data is equally proving the same. Then we have PGI campus. This is very interesting. In PGI, we can see that January we have the peak. So it means the admitted people also had, or we say the residents or whatever, like Chandigarh number of cases, we have the cases in PGI campus also. And this is what in January 2022. Then let me take you to, these are the total number of cases Chandigarh, and this graph is very interesting. This graph says that this is the first peak, which was in closely September 2020. Then we have the next wave, which was close to May 21 and June 21. Then we have the third outbreak of COVID-19, third wave, which was in January to February, you say 2022. And you see that one can draw a straight line to these peaks and their elevation is coming out to be 66.03 degrees. That is what I say is a coincidence or what, but we are getting this kind of presentation of these graphs. So this line which is joining these three peaks of three respective waves, the elevation is 66.03 degrees, right? And now we are here. This is the 10th of June and the cases are mild rising because we have the yesterday cases, I believe 25. So it's relatively very, very small because we have seen the cases close to 1500 per day, 1600 in some go. So that's a very small number. So from machine learning point of view, we need not to worry at present that the outbreak in Chandigarh, of course, we have to follow the COVID protocols, but from worry point of view, statistically, I say the number is very less as compared to these three peaks. So there is no peak right now. So now let me take you to how the graphs are behaving with respective machine learning approach, right? So I believe you can see this browser and coding. Could you please update me?
Yes, sir.
Okay, so my intentions are here to introduce you with regression and classification. I would like to tell you in advance that few graphs you will find meaningless with respect to COVID-19, but yes, you are right if you find meaningless because some of the techniques cannot cope up with that respective area of COVID-19. For example, if I say linear and polynomial regression, so its graphs are not helpful for me for these COVID-19 data of 2.5 years now. But if you see like decision tree algorithms or random forest, you find that data is really interesting. You know, the graphs you can easily project now that when and where the peak is observing. And when we look at the classification side of this, especially I will talk about KNN classifications or naive-based algorithm classifications or random forest classifications, you find that machine is doing reasonably good to give us an indication when to prepare and when not. So let's start with the regression, and in regression, look at this linear regression. So before I show you graph, I would like to update you that we have taken the COVID data. This is data of Chandigarh. I would like to show you how the data look like. So just wait. This is simple, you know, we have data of almost now up to 10th of June, 818 days data, right? And this of entire Chandigarh, right? And then we have used simple programming. We have used machine learning. So I have imported the packages of machine learning of scikit-learn, you can see here, right? And we are splitting the data accordingly. My try is always to get around the 1/3 is the test data. So what it means, the 2/3 is our training data. Training data is something for which we try to build up the model, and test data is we try to check the model, right? And let's come to its results. And these are some results, but look at the graphs. These are of linear regression. And of course, this blue line shows the trend. And this is not of our use, as I told you, because data is like that. So certainly we cannot use this type of technique. But here I, being a researcher, find one good indication that this blue line is my threshold somewhere. And this threshold is of 100. Isn't it interesting that yes, when your cases reaches 100 per day, be alert because the peak is coming. That is something interesting observation from this. But yes, we cannot lock that observation. You know, this is something we are getting a trend. Then we have polynomial regression. In polynomial, you see again this kind of blue line, very close to understanding of linear regression. As it is polynomial, so definitely it's not straight. But what is again interesting, it is again declining somewhere around 100. So somewhere if you have apprehension, so it proves that it could be right. Now, this is support vector machine. In support vector machine regression, we are not getting a very reasonably good trend because it tries to distinguish from regressing point of view, and really I'm not able to find. Maybe it is giving some useful information, but being a developer, I'm not able to get some concrete information from this graph right at present. But yes, now I'm coming to decision tree regression, which is I will say, giving a very good alert to me. And now look at this. This is the training data of decision tree regression for the COVID cases. And now attend this graph of test data of COVID cases in Chandigarh, right? And now see the nature of these both. Very similar, very similar. And that is merely decision tree regression. So the understanding of graph is so good that somewhere we can easily classify that if we have some data trend in future, we can say that whenever there is a peak, whenever there is not a peak, and with the understanding of that linear regression and polynomial, we can say if we apply a threshold of 100, we can easily classify, do we need to be in, peak of that pandemic or not? So that is some kind of observations I can assess. I may be wrong in that, but the graphs are, somewhere indicating this. And what is interesting again is random forest is a extension of decision tree. So we cannot expect much different results, although better results we will expect because random forest definition is group of decision tree. So if this is decision tree, so this is random forest, and see exactly same or better results than decision tree, right? And here we can see that only this third wave, data mild difference with respect to decision tree, but the entire indication is almost same. So yeah, these were all the regression algorithms, which, types of machine learning techniques. I will say my observation says that decision tree and random forest are of my use because they are giving me some good information regarding COVID data. And yes, if we have let's suppose future data, we can easily say that when that data is very close to previous data, so we can take the measures accordingly. Now let's come to another machine learning technique that is called classification, right? As I introduced you in my presentation, the classifications mainly use logistic regression, KNN, naive-based decision tree classification, random forest classification, support vector classification. So we have used all these algorithms and we have respective graphs for each. And one thing I would like to tell you in advance, that we have taken 100 as the threshold. And I just told you that why I have taken the 100, because I had this indication from linear regression, right? And multiple regression that 100 is something, a close to 100 figure per day if cases, or weekly average is 100, not 100 per day, but the weekly average we say is 100, then we have to be alert for that pandemic, because immediately we can witness the peak or close to that measures we need to take. So let's start with the logistic regression first. So this is how the logistic regression graph behaves. This is what machine learning is delivering to me. Machine learning is saying that at 100, we can classify this as the training data. So exactly that how your testing data will behave. So one thing is in our favor is that the nature of test data is very close to training data. So it means if we simulate or if we generate some on based of some assumption, the future data, we can be prepared in advance that how much we will face the challenges as we faced in earlier waves, right? So this is logistic regression. And we cannot expect the same kind of classification with other algorithms because each one is having its own mathematical understanding, on mathematical formulations behind that. So definitely different trend will come. So don't be surprised that you are getting a bit different as compared to other technique. And that's what make it a different technique from the other one. So look at this KNN. Now this is KNN. Just let me take you to previous one. You see the difference between gray and white, right? Very strict type. But in KNN, you don't find like this. Just one. Okay. So this is the KNN distinction for training versus test data. Now, this is where the first peak is ending. We can see that the difference relatively is not what is expected in test data. So this again proves our assumption that somewhere if we mark a distinction, let's suppose of 100 weekly, average, then we cannot say that we have a peak, right? So this algorithm is somewhere giving us an indication that that may not be a peak, the distinction of that white versus gray area. And now I take you to support vector machine, which did not do good as in regression point of view, but its classification side we see that is very interesting and very powerful result, because we are getting very clear picture how the two regions are separated. So similar way, the similar pattern, the test region is separated. And as I told you, the 1/3 data is taken randomly. It's not that I have split the test data on basis of some partial or some bias technique. No, it is random. Random because we can witness any data, right? In terms of pandemic, we really don't know what cases could come tomorrow, exact number of cases. So we have just trained the previous data up to 10th of June, right from 1st of October 2020. And these 2 years, close to 2 years data, we find that interesting trends, especially the peaks, second and third peak data, we can understand from classification aspect. And support vector machine is fully make us understand that we can have the same trend. Then we have the naive-Bayes, very strong statistical technique based on the Bayes theorem. And we see that this classification is again same. So if one algorithm you do not bank upon, you can see the other algorithms. And if each algorithm is giving same type of indication, I believe scientifically and mathematically, we have to accept that if such type of data we witness in future, the such type of challenges will happen. So that is, I believe, a very clear application. Now let's come to decision tree classification, which was a very good, we say, scientific output in terms of regression. And when we look at this classification area, again, the same type of results are coming. So I will say that for COVID-19 data, if you ask my personal choice, so I will say for regression and classification, I will go with decision tree and random forest in these two, because results are in front of you, right? They are giving as expected, almost same, especially the regression part. Then we have random forest, and the random forest, again, like decision tree. And some of you could have in mind that I have not taken any deep learning technique like convolutionals or recurrent. I would like to update you. Convolutional is for the static images, so may not be suitable for COVID-19. For recurrent, it could be helpful to us, but the idea is that it's not frequency. That's what we understand frequency from other point of view, but these COVID cases are something which are coming on daily basis, and with various lockdowns or some parameters, we are trying to control the cases or let the peak come down. So we really cannot make assumptions from our side that let's take data that way or this directions. We have to take it clearly that what the algorithm says and just input the data, right? So definitely deep learning technique, especially recurrent neural network, would have a more observation in that area, and the work is on. Maybe in future we can discuss that work of recurrent neural networks with respect to COVID-19 in Chandigarh. But right now, these all algorithms are indicating in one direction that yes, it is able to understand the data. And if we look at the sector-wise data also, as I shown you the graphs of sectors, somewhere we have a commonality that whenever there is a peak, we have to, or I say, I'm not expert in that, social aspect, so I cannot make any statement in that direction. But yes, somewhere it is true that every sector is behaving like that in Chandigarh. If there is third wave, so we have to somewhere accept it on the basis of graphs that every sector is observing the third wave. And that happened for the second wave also. And that's what we say the similarity we have observed in these second and third waves. And so far, these regression and classifications for the total data of Chandigarh is concerned, again, the results are, very promising in terms that, yes, if we have such kind of graphs are coming, we have to take the parameters accordingly so that we can control the cases. And the more you can study in, I believe there are many studies which are published in this area, especially in the Nature Journal from the medical practitioners' point of view, or we say other biorelated researchers. And but the results are there for mainly entire globe, that how in each country the COVID-19 spread and how its machine learning understanding. I have done this study for the Chandigarh only. And because Chandigarh is again, it's not a small city, it's a big city of closely 83 clusters, where 63 are sectors, other are sector also, but are named as villages or so. So closely 80 to 83 clusters. And the population of Chandigarh is again 10 lakh or plus, I believe. So definitely its results could help us to understand that whenever such pandemic or so, how we can take up the parameters in advance. So I believe that I'm able to finish my lecture before time. So I have kept 5 minutes for my questioning or any discussions for that. So this is from my side. Thank you. And please, if you have any specific questions, please ask. Yeah, am I audible?
Yes, sir.
Yeah.
Good morning, sir.
Yeah. Good morning.
At this side from Riyadh Bahar University. I am currently pursuing BPT. So my question is, what is the difference in use of test and train set?
What is the use of?
Test and train set means what is the difference between them?
Train set is something basically you have a data set and you have to prepare your model for future. So you don't know what is the future data, right? So we try to divide the data in two parts. One is train part and one is test part. We try to train the model on the basis of trained data, and then we check its results with respect to test data. So it gives an indication if the validation we find, that is the, the trend which are coming in that direction. So model is stable and giving the accuracy accordingly. So we can bank upon that if future data is coming in that direction or that type of pattern, so it is more likely the results are accordingly. So that's why we need train and test data.
Okay, sir. Thank you.
Yeah. So any other question?
So my second question is, like you explained in machine learning, the starting of the lecture,
Mhm.
So we put the output, like let's suppose we are putting the graph in
Mhm.
and the data. So we'll get the program at the last.
Once again, we are plotting the graphs and
Yes, sir. As the output, we are plotting the graph and the data. So we are, at the end, we are getting a program in machine learning.
yes, let me tell you, whenever we develop a model, that model is basically referred as a logic. And in 1959, the definition says it's program. So we say that is a logic, and the logic is embedded in the model. That's what the idea is all about. You have the data, you have the projected, or you have the output, and we are trying to build up a logic or a program which is in terms of a model. So please look at some web repositories where you find the model of a technique. So in that model, you find multiple parameters, the parameters like its support vectors in terms of support vector machines, you find the boundary regions, you find the threshold level, iteration level. So all these logics which human need to find out is what exactly these techniques deliver to us. So that makes up it model, or we say the logic behind that.
Okay, sir. Thank you so much.
Yeah. Yeah, any other question? So, yeah.
I think there is no such queries for now, but if someone is having a query, they can text or mail. So thank you everyone for taking the time to be here today. And we are immensely thankful to Dr. Anu Sharma for providing such valuable information on AI and ML and its application in real life. For his ideas and elegance of explaining everything, I mention my deepest sense of appreciation, and I also extend thanks to all the attendees for their enormous cooperation. And so we are proceeding towards the end of the session, but before that, I would like to share an important information to the students that we have received your entries and we are creating the group based on your preference. As selected by you guys. So we will be announcing the group by next week. So stay tuned till then. Thank you so much for sharing your time with us. Have a great weekend. Thank you.
Thank you, ma'am.
Thank you, ma'am.